This hydraulic circuit is a motor braking circuit. Motor braking simply means to slow down a hydraulic motor. Often hydraulic motors have a load attached. In this case, the flywheel represents the load on our motor. One of the issues that we see with hydraulic motors that have attached loads is that the inertia of the moving load is transferred into the motor once the flow to the motor is stopped. So what you have is a motor being driven by the load. Once that happens, it's no different than a pump being driven by an electric motor. So what ends up happening is if the flow to the inlet of the motor is blocked by, let's say, a directional control valve, the motor continues to apply vacuum to the inlet port, driven by the inertia of the load, causing cavitation, and that's damaging. Second, we also see that in some cases the motor cannot be allowed to simply come to a coasting stop. It needs to be stopped fairly quickly. So we're going to use a sequence valve to perform the function of a brake valve. It should be noted that this is not the valve that they normally use for a brake valve. Our counterbalance valve is the closest valve that we have on the trainers that would accomplish this particular job. Unfortunately, its operating parameters are outside of our trainer's pressure capabilities and what we would see with this motor as well, so it doesn't make for a very good valve to use in this case. But the sequence valve does the job very effectively, and it's easy to observe. So when the motor is going to come to a stop, what we'll have is the block center 4-3 DCV released. It goes back to the neutral position. The oil at this point is somewhat pulled on by the load, yet the pressure that builds up at port B will also be seen at the sequence valve. The sequence valve, depending on its setting, will open up based on the pressure caused by the load of the hydraulic motor. So if we set the relief valve at a low value, the motor will stop slowly. If we set the relief valve at a higher value, then the motor stops quickly. Since there is no provision to prevent cavitation in this circuit, some noise may be observed in the motor while it's braking. The check valve on the right side of the diagram is to ensure that the motor only operates in one direction. This is a pneumatic automatic circuit. It is identical in function to the hydraulic circuit you built that appears on page 143, but this one appears on page 148. As in the hydraulic circuit, there's a single initiating event that starts the actuator to move out. Once the initiating event has been done, that cylinder will move out on its own, strike the cam valve, and retract. One of the things that you might notice is there are fewer lines in this circuit. That's because it's pneumatic. The air is vented to the atmosphere. So, looking at the diagram, an air supply is fed to the push button valve in the lower left hand part of the drawing. When the push button is pushed, that air is sent through the valve from port number 1 through port number 2 to the pilot operated DCV. The lower envelope of the pilot operated DCV now engages, sending air from port 1 out through port number, and I have to look at this, that would be number 2 or 4 depending on the markings. The manufacturers determine that, by the way, but 2 and 4 are normally used for actuator ports. Anyway, if that's the upper one, then we would see air entering the cap end of the cylinder. The cylinder extends at a controlled rate of speed because it does have a flow control on it, metering in meter out configuration. So the cylinder extends, strikes the cam valve. The cam valve sends a signal to the opposite end of the pilot operated DCV, causing it to shift back to its original position, and then air moves through the DCV into the rod end, back out of the cap end, and the cylinder retracts and the cycle is complete. So, just like the hydraulic circuit, you push a button or pull a lever one time, the cylinder extends out to its limit and then returns to the rest position, and the cycle is complete. I would like to add too, because I know there's a question about this, the actuator should extend slowly and retract quickly. Look at the flow control and look at the orientation of the check valve. This sequencing circuit, this pneumatic sequencing circuit, shows up on page 149 of your lab manual. It is in function identical to the circuit on page 144. Since it's pneumatic, we have fewer lines. The operation is as follows. The clamp cylinder extends first, followed by the drill cylinder. The drill cylinder retracts first, followed by the clamp cylinder. Now, the way this is accomplished is by the use of a valve, a pneumatic valve. It acts just like the sequence valves. One of the differences you'll notice is that the valves shown here inside of a blue box appear as two-position directional control valves. So in this particular case, it's a little bit odd that they chose to show this valve as a DCV rather than a pressure control valve. But all that means is you can do it either way. Now, looking at the valves individually, you'll notice there is an in port that is actually marked like that on the valve. The secondary port is the one with no markings, and we assume that it goes to the actuator. Now, to determine which of these cylinders is the clamp and which one is the drill, look at the flow path. Notice that the valve that's in the lower part of the diagram comes from a T connection that leads to it as well as to the cap end of the cylinder at the top of the drawing. Therefore, the cylinder at the top of the drawing would be the clamp cylinder, and you might want to just write that underneath that cylinder to help you understand the circuit. That means that the one at the bottom is the drill cylinder. Here's how it works. Once air pressure has been set and the system is ready to run, the push button DCV is pushed. Then we see air coming out of it, going into the lower envelope of the pilot operated DCV, and it shifts. Air then out of the actuator port starts moving toward the cap ends of the cylinder. So this would be the upper line. Now, the airflow is stopped from getting to the lower cylinder, seeking the path of least resistance. It moves on to the upper cylinder, and the upper cylinder extends. Once fully extended, the system pressure will begin to build, and the lower valve eventually will open, allowing the drill cylinder to extend. The drill cylinder then fully extends, touching the cam valve, causing an air signal to be sent to the upper envelope of the pilot operated DCV. It shifts back to its original position, where now the airflow is headed toward the rod ends of the cylinder. So if we look at the lower line, what we see is air is allowed to run to the drill cylinder freely with no restriction, and the drill cylinder retracts. Once fully retracted and the pressure builds, the valve in the upper part of the drawing now opens up and allows air to go to the clamp cylinder. It fully retracts, at which point the complete cycle is done. This continuous reciprocating pneumatic circuit is found on page 150. The chief components are an input, a three-way push-button DCV, two cam valves which act like limit switches, and a pilot-operated DCV in the lower middle part of the drawing which controls the movement of the actuator. This circuit has an on-off function. It requires that the push button valve be held in place for the circuit to operate. So normally the push button valve has a blocked port, that would be port number 1, and number 2 is exhausted to the atmosphere. When the air has been set and the push button is depressed, air is allowed to go to the pilot operated DCV. Now, if you look at the pilot operated DCV, the envelope to which the lines are connected, that is the normal position, and it shows us that the double acting cylinder is normally retracted. Once I depress the lever on the three-way DCV, then we shift the valve and the cylinder extends. Now that signal will bleed off. Once the cylinder extends and strikes the other limit switch, then what will happen is another signal will be sent to the other side of the pilot operated DCV, and then it will retract, restriking the other limit switch, resetting the airflow back to the pilot operated DCV through the push button valve. So it's operating through the push button valve. At any time the push button is released, air is sent to the right side of the DCV symbol, the pilot operated DCV, and the cylinder will return to the retracted position. While the lever on the 3-2 valve is held in, the push button valve that is, while it's held in, then the cylinder will continue to extend and retract without stopping. And this demonstrates a continuous reciprocating actuator circuit. This completes the second part of Chapter 13. If you have any questions, remember to email me and I'll get back to you as soon as I possibly can. This is a very difficult time for all of us, and as long as we each make an effort, I know that we'll get through it. Thanks.